Okay, so now instead of graphing points, we're going to graph a plane, which is kind of similar. So once again, to graph a plane by hand, you can't really draw a piece of paper. So we're going to draw a triangle to represent the plane. So what I do is I have 2x plus 3y plus 4z equals 12. Now I want to take you back to Math 1, where if I want to find the y-intercept of an equation, okay, a lot of you said get y by itself and tell me what b is, but we don't need to do that. If I need to find the y-intercept of an equation, I could plug in 0 for x and solve. Because think about it, if I am on the y-axis anywhere, that point is going to, hold on one second. You can go ahead and cross. Yeah. That point is going to be on the y-axis. So like this could be the point 0, 6. This could be the point 0, 4. So that's why we plug in 0 for the x. Likewise, if I want to find the x-intercept, I'm going to plug in 0 for the y. Same thing. So that's exactly what I'm going to do here, except if I want to find when I'm on the x-axis, so if I want to find the x-intercept, not only am I plugging 0 in for y, but I also plug 0 in for z. So when I do that, I'm left with 2x equals 12, because these both are 0. So that means x is 6. So I go on the x-axis here, and I plot a point at 6 on the x-axis. To find the y-intercept, same thing. I'm going to plug in 0 for x and z. That'll leave me with 3y equals 12. So I end up getting y equals 4. So on the y-axis, I'm going to plot a point at 4. Last but not least, the z-intercept, which means I plug in 0 for x and y. I am left with 4z equals 12, which means z equals 3. So on the z-axis, I go 1, 2, 3. And to kind of represent the plane, I'm going to kind of connect them with a triangle, hopefully a straighter one than mine. But that's the plane that kind of cuts through. And voila, it's that easy.